We have to discuss what is the path of electron in a uniform electric field. Now see, these are the positive plate and these are the negative plate. The electric field is vertically downward from upside to down, from positive to negative, and an innocent electron is entering this electric field like this, which is having a mass m and having a horizontal velocity v0, and it's entering the electric field. Now what will be the trajectory? What will be the trajectory? That is the path. What is the trajectory of this electron? That we have to find over here. So we are going to work out trajectory of an electron in a uniform electric field. Now let us see what kind of force acts on electron. When a particle is in an electric field, it experiences a force where F is equal to Q times of E. Q is the charge and E is the intensity of electric field. But you know that field or the force on the positive charge is in the direction of the field. But the force on a negative charge, which is an electron, must be opposite to the direction of electric field. So when an electron comes over here, it experiences an upward force. It experiences an upward force. I repeat, the force on electron is opposite to electric field. So the force on electron must be equal to the charge of electron multiplied by E. The charge of electron is small e multiplied by E. This much force acts upon electron in the y direction, in the vertically upward direction, E times of E. So this is the force acting on electron. Now due to this force, electron will have some acceleration in the y direction, where the formula for acceleration reads force divided by mass. So the acceleration of the electron in the y direction is E divided by m. So this is the acceleration of electron in the vertically upward direction. Now we have to consider what is the path of this electron. So we will consider two motions of electron. First, in the x direction. So first we are going to consider the motion of electron in the x direction. So in the x direction, if you see, what is the initial velocity of electron? Yes, it's v0. The velocity with which it enters the field, it's v0. Okay. What is the acceleration of electron in the x direction? It's 0, because electron doesn't have any acceleration in the x direction. जो भी acceleration है वो सिर्फ y में x direction में है. What is the displacement of electron in the x direction? The displacement must be equal to the length of this plate, that is L. The electron will move from here to here. Finally, we need to find this angle, the trajectory. What is the path? Okay. Now what? We need to find time. So what's the equation we are doing? We are using S is equal to ut plus half at squared. Class 9 physics, you all must be knowing. So in place of S I put L, in place of U I put V0, in place of T I put T. And this term will be 0 since acceleration in the x direction is 0. So from here we get time is equal to L divided by V0. This much time is taken by electron to pass this electric field. How much time? T is equal to L divided by V0. This much time is taken by the electron. So in this much time, the electron will cover the horizontal distance of this much. Is it clear? Is it clear? Okay. Now I am going towards the y motion or the y direction motion of electron. Motion in the y direction. Now what is the motion of the electron in the y direction? Let's find it out. The displacement in y direction of electron is unknown to us. Let us assume this displacement this much as y. So I assume this is displacement as y. What is the velocity in the y direction of the electron? So initial velocity in the y direction of electron must be equal to what? 0. The electron has no velocity initially in the y direction. It has entered the field horizontally. What is the acceleration of electron in the y direction? Yes, we have found it out. It is E divided by m. Now we are going to find two things. Yes, I am literally speaking. We are going to find two things. First, what is the final velocity of electron when it emerges out of the field? And second, how much time does it take? Now the second part is very simple, because the time taken by electron to cover this much vertical distance is exactly equal to the time taken by electron to cover this much horizontal distance. What is the horizontal distance? L. And it is covered in the time period of L divided by V0. L divided by V0. So this is the time it takes to cover the vertical distance y, L divided by V0. Now I need to calculate what is the vertical velocity of electron when it emerges out of the field. I need to calculate this Vy. So what it is? Let's calculate it. So we'll get, using the equation of motion, V is equal to U plus AT. Now V in the y direction is equal to initial velocity in the y direction, that is 0, plus acceleration in the y direction E by m multiplied by the time in the y direction. What is the time? It is L divided by V0. The time has nothing to do with the y direction or x direction. In the same time in which the electron covers this vertical distance y, it covers the horizontal distance L. In which it covers vertical distance y, it covers horizontal distance L. So velocity in the y direction becomes E divided by m multiplied by L divided by v naught. This is the velocity of electron in the y direction, E divided by m multiplied by L by v naught. This is the vertical velocity of electron when it emerges out of the field, that is over here. Now I need to calculate this angle theta. Now notice how I do that. At this particular point, electron basically has two components of velocity, one in the y direction and one in the x direction. In the x direction, the velocity of electron is constant because there is no acceleration along the x direction. But along the y direction, the velocity of electron has increased and it has become what? It has become E divided by m multiplied by L by v naught. I need to calculate this angle theta. Now from simple mathematics, you can say tan theta is equal to Vy divided by Vx. So I put the value of Vy, E divided by m multiplied by L divided by v naught upon Vx, that is v naught again. So I am getting it to be equal to L m upon v naught squared. This is the angle, or this is the tan of the angle. Now you can easily get theta is equal to tan inverse of this answer. This is the angle that the electron makes with the horizontal direction when it emerges out of the field. Now this is the trajectory of electron and this much angle it substitutes. So when an electron enters a vertical electric field with a horizontal velocity, the horizontal velocity of electron remains constant throughout its path and the vertical velocity increases from 0 to some value due to the electric force acting on it, which is opposite to the direction of electric field. That is the story. Thank you.